Now we've already learned how to translate, which means slide around many other graphs. We can slide around parabolas, exponentials, cubics, hyperbolas, even circles. So now, if we know the form of a basic absolute value function like this, which we know is just like our old favourite line, y equals x, that should be very familiar, we can draw that in there in black. Then all of the same rules that we've already learned apply to the rest of these. We can move this up and down by just tacking onto the end a number. Now remember, this would be like, if I'm adding 2 here, it'd just be like having y minus 2 over there. So this is going to lift our graph up 2. And if we want to draw that, just come up 2 and away you go. It looks just like that same v, but up there. We can label that absolute value of x plus 2. Similarly, if we want to drop it down by 1, then tacking that minus 1 onto the end, we'll just drop our graph down 1. Now this is interesting because you might have thought, hold on a minute, didn't you say absolute value functions couldn't go below the x-axis? Well, they can. This basic one couldn't, but this one can. And to work out that it can, let's sub in a value, say x equals 0. Absolute value of 0 is 0, so y will equal minus 1. And sure enough, it goes down there. So that's okay. You just need to understand that the ones that haven't been lifted up or down aren't going to go below the y-axis. Sorry, the x-axis. Now, what's going on here? We've done the minus 1 here and the plus 3, and they're not tacked onto the end. They're actually bounding closely with what the x is doing in this function. Now, what is the x doing in this function? It's sitting inside absolute value brackets. So if that minus or plus something is also sitting inside the brackets with the x, that tells you it's shifting left to right. We remember that the minus is shifting right, so this one is going to the right 1 unit. Let's draw this one in red. So going to the right 1 unit from where our black one is just going to shift it across 1. So it's going to come over here, and then it's going to sit right on top of this purple one over this side, isn't it? So it's on its own here, but it's definitely sitting on top of something else on this side. That's y equals absolute value of x minus 1. And this one here, it's going to be moving to the left 3. How do I know it's left? Because it's plus, and we know that that moves to the left 3. So it's going to go not here, but 1, 2, 3 across. So it's going to go up like that, same angle as all the others. And now to see where it's going to go through, I know it has a 45-degree angle because it's just like our line y equals x. So if it's cutting through at minus 3 here, it's going to cut through at 1, 2, 3 up here. And that gives me a nice, easy way to draw it. Ooh, a little bit wonky, but we get the idea. This is y equals absolute value of x plus 3. Now, can I move it side to side and up and down at the same time? Well, of course I can, and so can you. Minus 4 means that we are going to be moving which way, right or left? Yes, you got it right, it's right. We're going right 4, and we're going up 2. So if we'd like to draw this one, let's do this one also in black. We take our normal point, find the point first. Let's move it right 4, 1, 2, 3, 4, and up 2, 1, 2. Is it sitting right where that line is? No, I think it's a bit below it. Here. And so we're sitting at 4, 2. And if it's going to go up at an angle, then the angle is going to have to be 45 degrees. So if it's going across 4, it will need to go up 4. So it'll cut through here and sit up like this.